Hey guys, tonight we are going to be talking about angle measures. And so it's going to be a little bit of review of things you know, but we're going to be asking ourselves, how do I determine the reference angle of an angle in any quadrant? So that's your essential question. Make sure you copy it down. The first thing we're going to review here is we are going to review the quadrants. So this is just a quick reminder. You're going to go, duh, I know these things. But remember, we always start in this first quadrant. We have this is quadrant 1. That's where both of your points are positive. And then we're going to have quadrant 2, 3, and 4. Okay? Then remember, it makes that C going around the origin. The other thing we need to know about our lovely coordinate plane are the degree measures of each of these important axes. So you're going to start at 0 degrees. This guy is going to be our 90-degree angle. This guy is 180 degrees. This one down here is 270 degrees. And then when you come all the way back around, this is 360 degrees. So again, it just goes in the same C, the counterclockwise C that the coordinate or the quadrant's going. The next thing we're going to talk about is kind of the parts of an angle. So we're going to draw an angle off to the side. And on an angle, you have a couple of important things. So the first thing is you obviously have your angle measure. So you know that's however big the angle is. The next important thing that you need to know about it is this side on the bottom, which is what we call the initial side. It's where your angle starts. And when we're talking about angles on the coordinate plane, our initial side should always be the x-axis. And we're going to talk about that a little bit later. Then finally we have this guy. Well, I totally didn't trace that very well. And this is called the terminal side. Where does your angle end? So whenever they're asking about where's the terminal side, what quadrant is the terminal side in, they're just talking about where did your angle end, if your initial side is going to be the x-axis. Okay, so let's kind of get our feet wet, draw a couple angles in on a coordinate plane, and we'll start talking about more vocabulary. So the first thing is we need to sketch a graph of each angle. And so when we get to, when you have those acute angles or you have less than 90-degree angles, those are pretty straightforward. They're all going to be in quadrant 1. It's when you get to these little bit bigger angles that you're like, whoa, where do I go? So when you're sketching an angle, 137 degrees, first of all, you know that that is bigger than 90 degrees, which is your y-axis right here, but it's less than 180 degrees. So it's happening somewhere over in quadrant 2. So it's okay if you just kind of eyeball it. It doesn't have to be perfect. And you know we're always going to start with our initial side on the x-axis. So this angle right here is the angle 137 degrees, or it's a sketch of it. It's not perfect. And so this angle has a terminal side in quadrant 2. Okay, so that's if you have a positive one, you go counterclockwise. Now when they pull up and they have a negative angle in here, like on number 2 where they want us to sketch negative 60 degrees, you're still going to start with your initial side on the x-axis. But now you're going to go the other direction, and this negative is going to tell you to go clockwise instead. So you go opposite of the regular way. And so 60 degrees is still going to be an acute angle, so it'll fall in this quadrant down here. Wow, that was pretty bad. But it's a sketch. It's okay. Don't have to be perfect. So this right here would be your negative 60-degree angle. So when you're thinking about the positive or negative, positive goes counterclockwise, negative goes clockwise. Okay? So we have negative 137 degrees. Again, we're going to start with our initial side on the x-axis, but then we're going to be going clockwise because it has a negative. So again, I know it's kind of like you flip it upside down. I know that it's not going to be an acute angle, but it's not more than 180. So he's going to be over here, and so my angle measure goes there. That would be negative 137 degrees drawn on the coordinate plane. Okay, so that's how we would sketch angles on the coordinate plane. Let's talk a little bit about coterminal angles. So go ahead and write down this definition. Coterminal, the phrase coterminal, just means that your angle ends in the same place as another angle. So you're looking at two angles that have the same ending side. They don't have the same angle measure, but they have the same ending place. So it says, for example, 4, we're going to find 3 different angles that are coterminal to 20. So they're going to look exactly the same as 20 degrees, but it's going to, like the circle that we went to get there might go a different direction, etc. So first of all, we got to sketch 20 degrees in there. So my 20-degree angle is going to be an acute angle in quadrant 1. So we're going to have this guy is 20 degrees. Okay, remember we start with our initial side on the x-axis. The most obvious coterminal angle to this guy is going to be the one where, remember, to get to this 20-degree angle, we went counterclockwise. If instead you go clockwise from the x-axis right here, that's going to give you an angle that ends on the same spot. And in order to figure that one out, remember we had that a whole circle has 360 degrees. So if I take 360 minus 20, that would get me 340 degrees. But remember, since I went the opposite direction, it's going to be negative 340 degrees. So that's one coterminal angle to 20 degrees. It's just taking it going the opposite direction, the completion of the 360. Okay, to find some other ones, there's a lot of ways we could do it. One way we could do it, remember, we're trying to get to right here to make that 20 degrees. So if I go ahead and I make this, I still go the same direction, but instead of stopping at 20, I go all the way around and then stop at this 20 degrees. All I've done here is taken that 20 degrees and added 360 to it, and that's going to be the same angle. I just went a little farther to get there. I went all the way around the circle. So this one would just be 20 degrees. Hold, please. This one would just be 20 degrees plus 360. I went around the circle all the way. So this one would be an angle measure of 380. Because again, it's the same angle, it looks the same, I just went around a little bit more. Okay, the other thing I could do is I could continue adding 360 and I could get that angle measure. But I could also, right here, if I decided to do the counterclockwise thing, again, I could go counterclockwise and then go one more time and make like a big old snail. Okay, and so again, I'm going clockwise, which means I have a negative angle, and if I add 360 to 340, then that would get me 700, and I went in the negative direction. So these are 3 different angles that all end in the same place as 20 degrees. So really, when they ask you to find coterminal angles, you just need to plus or minus 360 degrees as many times as you need to. Okay? So as many times as you need to do this, plus or minus 360, and that will get you coterminal angles. Okay, the next thing we need to talk about are reference angles. The whole reason that we're doing this one for angle measure. Well, I skipped a page, sorry, 1 second. There we go. That was a scary moment in my life. I was like, no. So first of all, a reference angle. The first thing you need to know about reference angles is they are always acute or possibly 90 degrees. So basically, they're less than or equal to 90 degrees and bigger than 0. Okay, they are formed by the terminal side of an angle and the x-axis. So if this is a reference angle, it's going to be on a terminal side of an angle and then the x-axis. Okay. The other thing about reference angles is they're always positive. Even if they're underneath in quadrant 3 or 4, they're always going to have a positive value because they're kind of what we're referencing in order to find trig values later on. So let's go ahead and kind of talk about what the reference angle even means. It says find the reference angle for each of the following. Well, 50 degrees. This guy, this is acute, it's less than 90 degrees. If I draw it in here, this would be my angle. Remember, it goes up from the x-axis. So the angle that I'm looking at underneath over here, this would be my reference angle. 50 degrees is the reference angle. It starts on the x-axis, it's an acute angle, and it's formed by that terminal side of the angle and the x-axis. Okay, now if I sketch 130 degrees, that's one of the ones that's going to be over here in quadrant 2 because it's more than 90, less than 180. And so I went this direction. Now the thing about the reference angles is, first of all, they have to be acute. 130 is not acute. The other thing is they're formed by the terminal side of the angle, so this side, and the x-axis, so down here. So this is going to be your reference angle for this particular angle. So when I look at this, if I wanted to find what that value would be, I would simply take 180 degrees, because that's what the x-axis is, minus 130 degrees, and I would find out that the reference angle for that guy is 50 degrees. Okay, so they're the same, they still have the same angle, so if I was to find, you know, the triangle that was formed by that angle, it would be the same type of triangle. Okay, it still works if you have a negative angle measure. So when I have negative 120 degrees, remember I'm going to go clockwise, and then I'm going to be down here. So I went this direction. But again, your reference angle has to be formed with the x-axis, so it's going to be this direction here. Now this angle is also going to be positive. So even though I went negative 120 to get down there, I'm just thinking about if I took a protractor and measured this angle right here, how big of an angle would it be? So I'm just not going to worry about the fact that it was a negative 120, and just find out how far is this terminal side from the x-axis. So that's going to get me 60 degrees. So this reference angle is 60 degrees. Okay, last but not least, we have 705, which I have no idea what that looks like. So if I think about this a little bit and I take one of the rotations out of it, that gets me that it's a 345 degree angle. So that's really, really close over here to the end. Okay, but remember, I had to go around a couple times, and so I went one whole rotation, and then I went one more. So that would be how I would draw 705 degrees. Now, if I'm looking for the reference angle of that guy, again, it's whatever's formed with the x-axis. So this would be your reference angle in there. So I could just take 360, subtract the 345 that I went around, and I would find out that that was a 15 degree reference angle. Okay, so again, reference angles are always going to be less than 90 degrees or possibly 90 degrees. They're formed by the terminal side of the angle and the x-axis. So you always have to look, where is your x-axis, and then we're just going to call them positive even if they're underneath the x-axis. Okay, we're going to do one application problem for this thing, and what they're going to ask you to do is find the exact values of the 6 trig functions, so sine, cosine, tangent, all of those things, of an angle theta whose terminal side passes through the point negative 4, 3. So the first thing I recommend to do, if there's not a picture, you should just draw it. And I'm going to go find out where is this angle. So at negative 4, 3, here's the point. And I'm going to go ahead and sketch in that angle. Oh, look, I have a line. It looks much nicer. And so when I'm looking at that, I want to find trig values. And we know our SOHCAHTOA when I'm doing trig values, which means I need to know some side lengths. So when I'm looking at this triangle, I'm going to use the reference angle right here. So if I look down, and this is the guy that I'm worried about. Okay, now I'm looking at side lengths here. So if I know that I went up 3 to get to this point, this length is 3, I went over 4 to get to this point, so this side is 4. Now the one thing we do have to remember is it is a negative 4, so I'm going to make this length negative. So now I have a triangle that I could do something with, and since I know that this is going to be a right triangle, since I dropped an altitude down, this is a 3, 4, 5, or you could use Pythagorean theorem if your numbers weren't so nice. So now I have a triangle that I can find trig functions for. So we're going to go ahead and go through all 6 trig functions. First one I'll do is sine. So sine is going to be your opposite side, and this is your theta, just in case you didn't catch that. This is your theta value. That's the angle that I made, and there's the terminal side. Okay, so now I'm going to say that my sine is opposite, which is 3 over 5. Done. And we are looking for exact values, so we'll just leave them as fractions. The cosine of theta is going to be your adjacent, so that value is negative 4. Yes, you need the negative sign. And then 5. Okay, so 5 is your hypotenuse. Then you're going to do your tangent of theta, which is going to be opposite over your adjacent, so negative 4, so you could either put 3 over negative 4 or negative 3/4. Now we need to do our reciprocal values, so the reciprocal of sine is cosecant of theta, and since I already found sine, it's pretty straightforward, just flip it over. Same deal for secant. Don't forget your negative. That negative is still stuck in there, so it's negative 5 over 4. And last but not least, we have cotangent, which gets you -4/3. Okay, so that's all about angle measure. When you're looking at angles of your coordinate plane, remember, you're trying to answer your summary, you're trying to answer that essential question, how do I determine the reference angle of an angle in any quadrant? I will post the question stems on Twitter should you need to see those again for your column or your Q column. And I hope you've had a great weekend.